for folks to go back and see them later. And looks like you're already highlighted here for us, Mr. Irv. It's great because Intellitex is going to be our first pitch today. So whenever you are ready, go ahead and share your screen and we can get started. And we want to give it about 30 seconds here. I see some folks still joining. I think folks are still making their way over from the main stage.
Okay, that sounds good. Thank you, Evan.
Of course, super excited to see everyone coming in here. It's great to see some of these, government and government adjacent folks taking time out of the day to come see these pitches. We really appreciate it. All right. Why don't you go ahead, David? I think we have a quorum here.
Okay. Can you see my screen?
Yes, we can. We can hear you perfectly.
And you're seeing the Intellitex first slide?
Yep, and then just went to the second slide.
Okay. Let's see. So Intellitex is a company that was a spin out from the university. It is a spin out from the University of Maine. Focuses on smart materials and textiles. This particular material that we're going to show you today, these products that we're showing you are based in the area of energy and energy production, and also smart materials as integrated into textiles. We provide textile-based solar power and color solutions to users in the field. As I mentioned, we are a startup that from the University of Maine Technologies. We started in May of 2022, and further developing commercial applications for smart textiles developed through U.S. federal R&D programs here at the University of Maine. Our team composed of Christopher Erb, James Stahl, Dr. James Stahl, and myself as starters of the company. Chris provides technical and material solutions, as well as Dr. James Stahl and myself, and I'm managing the business part of the company. So the problem is power generation in the field. We assume that the dual use for this technology would be power for consumer products. So in one case, we have a photovoltaic material, which I'll show you in a moment. And the other is a problem of soldiers' well-being and soldier protection. And this is really geared towards a color changing filament that we're going to show you. So, so Intellitex has developed smart textile technologies that provide passive power and color change of critical assets. So a photovoltaic powered textile filament was developed, as well as a color changing technology based on filaments for textiles. Our company integrates these materials for low power communications and electronics, potentially for cloaking applications or EMI shielding, as well as power storage, capacitors, smart haptics, and integration of electronics and other artificial intelligence. So the first product is a photovoltaic material. It's a photovoltaic filament that is integrated into a woven fabric. And what you see here in the picture is actually it operating and charging a cell phone. The material is woven into a fabric as a single filament. So this is hundreds of these yarns integrated into a fabric. And as you can see, there are red and blue stripes on this material. Each one is sort of a polarity. So as you look at this fabric, you can see that they are sort of inverted as it goes across the fabric. The blue and the red are on the top and the bottom of the fabric. So they're stacked like batteries in a flashlight. And in this way, we can create any voltage or current scenario to make either higher voltage or higher current. So each filament produces about 1/2 of a volt DC, which then coupled with small power and low power devices can power things, anything from GPS locators to, ways of charging batteries. It can be configured in series or parallel, as I mentioned, and could also be integrated into a fabric to create, to utilize capacitors as well as other energy storage methods. The next technology that Intellitex is developing and commercializing is a filament that changes color on demand. So what's unique about this particular technology is that the filament can be changed throughout the spectrum of the color spectrum. So we can control the filament throughout the spectrum, which is unique. Many color changing technologies, and I'll give you a good example, would be, say, the color changing cup that you got as merchandise at the conference. It will go from blue to green, but a single color change. Whereas this technology, we can control throughout the whole spectrum of the colors. So in theory, we can have any combination in the fabric that has to do with any combination of color change patterns. I see I'm getting a note here that I have a minute left, so I'm going to make it very quick. Then beyond that, our capabilities to create this material is we have a coating line that we utilize, and we are experts in weaving and textiles as well as coatings. What do we need? Intellitex and the partners have developed this incredible technology. We're looking for development partners and funding to further this technology. The refinements that we're looking to develop are busing systems to quickly integrate these materials into known manufacturing methods for textiles. So these would be busing, magnetic wires, non-metallic substrates, more durability and flexibility in the case of each of these technologies, and fabric integration. With that, I'm going to end my presentation and say if you have any questions, you can join our booth, and we'll be happy to answer the questions that you may have. Evan, is it appropriate to ask if there are any questions now, or do I need to stop?
No, we'll save questions for the rooms there, so that we have maximized times that they can have one-on-one conversations in the room. But if you have any questions you can think of, also feel free to shoot David a message here privately in the Zoom chat or through file a direct message. It's another way you can ask questions there as well. Thank you, David. Great presentation. Like David said, please join him in his follow room after for any follow-up questions and to get to know Intellitex a little bit better.
Thanks for keeping me on track, Evan.
Of course, that's what I'm here for.
Okay.
All right. Next up, we have our team Hydrolist. I'm going to spotlight you here, Kirsty. 1 second.
Okay, and I can imagine that everybody can see my screen, but holler if you can't or can't hear me.
We're good.
So good morning, everyone. Thank you for joining and for the opportunity to present today. I'm here today representing my company, Hydrolist, to speak on how we are helping provide green energy material solutions. So to begin with a couple introductions, my name is Kirsty Gildemeister. I'm the CEO of Hydrolist. My co-founder, Kelsey Fitzgerald, and I both have private industry and university research experience in metallurgical and materials engineering. And we've also become experts in a unique coating technology known as plasma electrolytic oxidation. Our coating technology and application is actually a patent pending process held specifically by ourselves, the company Hydrolist. So to begin, I want to talk about how we began our involvement in hydrogen fuel cells with Kelsey's off-grid tiny house in Kentucky. It was built in a remote location and powered with a solar array and battery bank. However, he found that his entire battery bank would charge before noon, and he wasn't able to capture any more energy. Then when he had periods of high energy use and low sunlight, he would drain that battery bank. What we realized was that he had a problem with energy generation diversification, and the battery banks weren't sufficient for energy storage. After some research, we learned hydrogen fuel cells could solve this problem. So similar to Kelsey's energy storage issues, the DoD is facing a challenge in developing energy resiliency systems. Domestic bases have been tasked with organizing contingency plans for energy supply during a national emergency, with the goal of initially being able to support a base for 30 days, 90 days, then farther out. So some technology that's currently available is the grid. But obviously in a national emergency, that's not a possibility as it might go down in that emergency. Again, solar energy and battery banks, they provide limitations, same as what I previously discussed. And lastly, gas generators. Typically, fuel supply is the most strained in a national emergency, and any reserves are better used in vehicles. So we have to come up with alternative energy generation and storage solutions. So not only are there a number of commercial applications, which I can speak more on in our booth, but we've identified 4 main uses for hydrogen fuel cells within the DoD. The first being domestic bases. As I mentioned, hydrogen fuel cells can be used day to day or in that national emergency scenario where energy generation needs to be provided. Foreign bases, it can be used in foreign bases as this provides on-site energy generation and supply and provides independence from a foreign government or reliance on a fuel supply and support, which in the case of a national emergency is likely to be a worldwide concern. Another use case for the DoD are in forward operating bases. Fuel supply chain is a major factor in determining the location for these bases. With fuel cells, there's more location flexibility and less dependence on a fuel supply chain, which might be tenuous. And another or last use case that we identified is in the warfighter. So this is a really different case from the bases. Hydrogen fuel cells are scalable in size, so they can be as big as a shipping container used on a base or as small as a communications radio. Hydrogen fuel cells are also lighter and can provide portable energy on demand, portable energy generation on demand for life-saving uses, as well as mission operations uses. So how do we fit in? Hydrogen fuel cells are currently expensive, so the cost to produce hydrogen is greater than natural gas. However, 40% of this cost is attributed to a component in a fuel cell called a catalyst. Catalysts are also consumable pieces and require periodic replacement. Most current catalyst technology involves coating expensive nanoparticles on a substrate and sintering them in place. Imagine gluing metal to a piece of wood. We are changing this method using a technology that essentially microwelds these materials in place. This method provides an increased catalyst lifespan by increasing the wear resistance and corrosion resistance, and it also provides the same or better efficiency to competitors. It can also be made in many sizes, so the portable size or storage container size can be provided. And the kicker is that it's roughly a quarter of the cost of current commercially available catalysts. We work with a number of organizations on this project. Obviously, through NSIN funding, we were able to participate in this program and also are close in contact with our local NSIN affiliate. We have lab space on South Dakota Mines campus and have access to testing equipment through them. We've also been working with a group called Nanocoatings Incorporated, who have a lot of experience in this technology, in the same technology we're using. They just use it for different applications. Lastly, Decode, who obviously have been here with us through this program. So looking forward, we're working on more lab scale and bench prototyping as we're at a TRL level of about 3. So to that end, we are pursuing funding and more DoD partnerships and commercial dual uses and strategic partnership. Looking forward, we're submitting a packet for the DOE Hydrogen Shot Incubator, as well as this upcoming SBIR Air Force opportunity. With that, I hope to see you in our booth.
Fantastic. Thank you, Kirsty. I'm still waiting for my invitation to Kelsey's tiny house out there, but we'll see down the line. No, please go talk to Kirsty and Kelsey over in their booth after this. There's some really awesome uses for their technology. I'm excited to see what you guys all come up with. All right, next up, our next team pitching will be the team Aeroflow. Aeroflow, so Sherry, let me spotlight you here. All right, go ahead and share your screen.
Okay, let's do that. All right, so I'm assuming you're seeing my slide deck and not the presenter view, correct?
That's correct.
All right. So, well, thank you for giving me the
opportunity. Actually, we're not seeing the full. We're still seeing the full PowerPoint screen there. I misunderstood what you were asking.
Okay, let's try this one more time.
Well, that's good. If you want to share it, if you want to go full screen first and then hit share, that should work.
Does that work?
There we go. Yep.
Okay. All right. So thank you for NSIN and Decode to give me this opportunity to share our work on making tractor trailers more aerodynamic. If you saw the inflation report today and saw the price of gas or diesel, this is the place where you want to be to make your vehicles more aerodynamic. So why do we care about that idea? Well, let's see what tractor trailers provide for the US economy. So the transportation of everything in the United States relies heavily on tractor trailers. This could be for food, fuel, healthcare, waste disposal, manufacturing, and retail. The American Trucking Association likes to say, when truck stops, America stops. And this is not a joke, because about 80 to 85% of goods in the United States are transported on large Class 8 tractor trailers. So what's really the problem with these systems? Well, first, let's see what they do in terms of the economy. There is a very large amount of revenues associated with trucking, including the transportation of goods. And there's lots of miles traveled. In particular for the DoD, I'd like to point out that the recent Defense Logistics Agency report has highlighted the need to significantly increase fuel efficiency for these heavy vehicles. Why? Because they suffer from poor fuel economy. Large tractor trailers range anywhere from 4 to 6 miles per gallon in terms of their fuel efficiency. The simple idea is, if we can improve fuel efficiency, we can make shipping cheaper. So what is out there that is already being done to make these systems better? First, there are what we call traditional retrofits, which could take the shape of either trailer skirts or the boat tails that sit behind the tractor trailers. Typically, these will yield about 8% in fuel savings. There are wheel covers that are more recent in terms of their innovation, and a few have been sold recently, which lead to another 2% in fuel savings. Where does our innovation come in? We target the largest surface area system in a tractor trailer, the trailer itself, by making the sidewalls and the roof, if it is chosen to be, more aerodynamic through a series of innovative structure designs that can be attached onto the existing flat plate structures. Our system provides, or these attachments provide, significant reduction in drag, which translates to about 6 to 8% in fuel savings, which at today's diesel price would be at a minimum about $4,000 per year per tractor trailers. It is worth noting there are more than 2 million tractor trailers in service in the United States alone. The other advantage is our modular design, which permits easy integration either with existing systems and technologies, or if new trailer manufacturers are designed. We have been working and have reached out to a variety of partners. Many of these trailer manufacturers do work for the Department of Defense. There are large consumer goods and shipping companies that are interested in these technologies, as well as trailer rental companies. Given that there are so many heavy-duty trucks used in the United States, both commercially and for Department of Defense transportation needs, we believe our technology provides a significant competitive advantage. First, the intellectual property is protected with the patent already issued. And as far as we know, there is no similar competing product in the market currently. The dramatic fuel savings do exist for any customer, and it is an incentive for companies to go green. It is a passive structure which allows for easy maintenance and application of paint or other additives that may be needed. So who are we that we have come up with this idea? Well, I'm an associate professor of mechanical and aerospace engineering at the Ohio State University and partner with my co-inventors on this technology. We are supported by Ohio State's Technology Licensing and Commercialization Office, with Ryan being our lead in that area. So what do we want from this team here? We're looking for a partner that can be a strategic partner and help us manufacture these at full scale at 53-foot length for the full trailer testing, perhaps an early adopter, and also assist us in generating some funding to work with the regulatory systems. Should you have an interest or have questions, please feel free to come to our Philo booth, or you can reach me at this email here. I understand I'm almost out of time, so I'm going to stop and pass it back to Evan. Thank you, Evan.
Oh, thank you, Shaurya. As we joked around in the perfect moment here to come up with a gas and energy saving technology here as we continue to just see gas prices rising. So really excellent technology and great pitch, Shaurya. Thank you. All right, we are ready to move on to Sensotec. Sensotec, if you want to share your screen. Fantastic. And I will spotlight you for everyone. There we go, Raymond. And take it away when you're ready.
All right. Hey, everyone. My name is Ramon Soto. I am the founder and CEO of Sensotec Propulsion Technology Incorporated. And we are a fast growing sensing technology company that uses patented radio frequency sensing technology that's being used by all of the major engine makers to ultimately help keep engines online and running. And so just to kind of give you a sense of the problem, warfighters like the Air Force Program Executive Office C3INN rely on business jets to provide ground communication coverage for troops, so basically providing Wi-Fi in the sky in this sense. But business jets were used for commercial use, not really for military operations, and are now being pushed beyond their limits from use in austere environments. And so this subjects a lot of the parts to increased stress and temperature and creates a vulnerability in fleet readiness by exposing the engines to premature blade failure, and in some cases, catastrophic failure. And the enemy sees grounded planes as a vulnerability. To fill this gap, Sensotec has deployed a team of engineers, veterans, scientists, and executives to help warfighters gain an advantage by identifying and anticipating engine vulnerabilities early on with a propulsion health monitoring system that uses sensors directly on blades that were licensed out of several universities. And we place sensors directly on blades. This is used not just on engines in the Air Force or DoD, but is also being used currently in a power generation setting for land-based gas turbines as well. And we place these battery-free, high-temperature wireless ceramic sensors directly on blades that are spinning over thousands of miles per hour. They're battery-free. They don't require an external battery source. Next, we route antennas into the engine casing that's also high-temperature rated, that is communicating with the sensors as they're whipping by at high temperatures, high G loads, and high mass flow. We route the electronics outside of the engine casing, and while the engine is being fired up, we're outside of the enclosure where we're collecting data. And here's an example of a report that we delivered to several customers where the customer thought that the blade temperatures were only seeing 600 degrees centigrade, and our system was able to show them that they were actually operating at 900 degrees centigrade, approaching the metallurgical limit of the blade. And so from the work that we've done with the dual use technology, we have delivered systems to Siemens, GE, Rolls-Royce, Raytheon, also to other applications such as compressors. This can also be applied in hypersonic applications. And we have been recognized for the work that we have done. And so, Sensotec, we're committed to helping warfighters push the limits of combat effectiveness, from achieving enhanced fleet readiness to support warfighters such as the Air Force's mission to fly, fight, and win. So also, if you don't see your name up here and you would like to see your name up here as a customer, please feel free to reach out to us. I'm Ramon Soto, and I approve this message.
Love the ending there. Fantastic. And like Raymond said, if your name is not there, but you would like to see your name there, you know what to do. Head over to their Philo booth at the end of this session. Have a chat with Raymond. Sign up to have a further conversation with him. And hope to see that that deck, that slide on that deck, just continue to grow for you.
Thank you.
All right. Last but certainly not least, we have our team from Darcy Solutions. Darcy Solutions, going to bring it up here. Let me highlight you for a second here, Brian. 1 second before you start. Hold on 1 second here. Brian, is your camera on?
It is now.
There we go. I was having trouble spotlighting you and I couldn't figure out why.
All right. Thank you.
And if we should just share your screen again, we don't see your slides right now. Perfect. Now we're all set.
All right. Thanks, Evan. And before I get started, thank you to the whole Decode team. This has been a really, really helpful accelerator, and greatly appreciate all the lessons and insights that we've been able to gather through this process. So we're Darcy Solutions. We are a technology to really provide less of a product and I guess more of a service or quality of life, which is heating and cooling. And those applications are for both commercial and residential buildings, so office buildings and multifamily, barracks, whatever you can imagine for a building that needs heating and cooling. I'm Brian Larson. I am one of the co-founders and the CEO of Darcy. In terms of the needs that we're looking to meet and fulfill on behalf of the government, there's one that is becoming more and more predominant, and then there's one that maybe is lurking out there, but actually Kirsty talked a little bit about it in her presentation a few minutes ago. The first is, as we move through carbon reduction efforts to get to strategies that will reduce our carbon footprint, ultimately get us to net zero, the focus has now expanded to not only include transportation and electricity production, but also heating and cooling in the built environment. As you can see here, it's a big chunk of the emissions solution, and more organizations are setting their aspirations for carbon reductions, and those aspirations are starting to turn into requirements. And so addressing heating and cooling is a key component to hitting those reduction requirements. At the same time, you may have heard recently about what's going on in Texas. We certainly heard about ERCOT last January when the grid struggled to keep up with instant heating requirement of electricity-based heating. As we continue to see the electrification of many things, we will start to see that grid continue to be exposed to various events that will degrade its reliability. So those are the two needs that we are looking to meet, and think that our technology fits quite well with this. This gives a comparison of the different types of technology that can enable that electrification process, moving from carbon-based natural gas, coal, fuel oil fired heating over to an electric source. And as you can see, there are a number of different ways to do that. As it turns out, geothermal heating and cooling, as opposed to geothermal used for electricity production, but shallow geothermal, has been identified by the Department of Energy as the preferred choice for us as a society going forward, just because of its efficiency. It is the most energy efficient heating and cooling technology, and also the most environmentally friendly heating and cooling technology. The challenge with it up to this point is that it really hasn't penetrated the commercial applications. It's been primarily single family homes where it's been used. And one of the primary reasons for that is because of the footprint required. Geothermal works extremely well. It costs more to install up front, but then that premium can be paid back with lower operating costs over time. So we can solve the cost issue, but the bigger challenge then is, how do we solve the footprint issue? And our technology addresses that head on and makes geothermal applicable to a broad range of settings. How did we come about discovering this or coming up with this application? It's really taking a number of already known technologies and putting them together in a different fashion. Our technology was developed by my co-founder, Dr. Jimmy Randolph, and his research partner, Scott Alexander, who's now our chief geologist, while at the University of Minnesota in their Earth Sciences Geology department. And their focus has really been, how do we move away from a conduction-based system to a system that provides a much more efficient and effective energy exchange medium, which is groundwater. And that's where our technology has really been focused, is accessing groundwater and utilizing it to provide heating and cooling in a much more efficient way. You can see our partners here, the DOE, NSF, and so on. I want to quickly mention, we are at the point where we are now commercializing our technology and are looking for opportunities in a variety of spaces to take and build on the first 3 installations that we've done that are performing extremely well and apply them in new applications. This just gives a quick list of the types of applications that we could be deployed against. These can be commercial buildings, office buildings, they can be multifamily residential, and a variety of different applications, both for new construction as well as retrofit applications. So would love to talk to you further about the opportunities. Please visit at our booth, or feel free to reach out at the contact information listed here. But thank you very much.
Thank you very much, Brian. And thank you to all of our founders and teams here today. That was an excellent set of pitches. Some really cool technology. So I hope everyone here listening, at least one thing you're like, yes, them. I need to go talk to them. That was our final pitch, like I said. One quick housekeeping item for our visitor here today watching the pitches. If you go into the Philo room, the Philo platform, and scroll down towards the bottom, you'll see a very short 5-question survey. We would love if you took a minute and a half to fill that out. We're constantly iterating on this program and looking to make it a better experience, not just for the teams going through the 10-week accelerator, but for everyone who comes to this final pitch day and sees these pitches and interacts with the teams. So please take a minute if you can to fill out that survey. That'd be incredibly helpful. With that, it is time for us to move on to the conference portion of the events. So founders, feel free. I'm going to stop our recording here.